Hi, my name is Alain Legault, and welcome to CES 2019. I'm here today to talk to you about a new VESA industry standard called VDC-M, VESA Display Compression. We're introducing today this technology that was actually ratified as a standard earlier in 2018. With VDC-M, which is a more advanced set of algorithms, we're now able to push that video compression down to 6 bits per pixel, or even down to 5 and even 4 bits per pixel from some use cases. The reason for this new technology is that the display bandwidth requirements are keep increasing, and we feel that we need to push the envelope to the next step. Essentially, the idea is we're able to compress video that could be 8-bit, 10-bit, or 12-bit per component, so 24, 30, or even 36-bit per pixel. And we can, by software control, adjust the compression to hit target bit rate down to 6 bits per pixel while preserving entirely the visual lossless picture quality. One nice thing also about the VDC-M technology is the latency is extremely small. It's actually about a microsecond, which is totally not perceptible for humans. Let's go and have a look at our demonstration. Our VDC-M IP demo consists of 3 components: a PC laptop, an FPGA board where we incorporated our VDC-M IP video encoder and decoder, and a 4K by 60 frames per second display monitor where we're going to be looking at the picture quality result. The interconnect between the components go the following way. We're taking the DisplayPort video output, extended display of the PC laptop. We bring it in the FPGA board. First, we have the Hardent VDC-M encoder, which is connected to on its output to the VDC-M decoder, and then the output of the decoder goes directly to our display monitor. But there's also, beside, a bypass path that allows to look directly on the display monitor at what's coming out of our PC laptop, so we can compare the 2 images. So let's have a look. So on my display monitor, I have an overlay here which says what I'm looking at. And as we can see, it's flickering between uncompressed input and VDC-M output. And the reason for this is to allow to see whether there are any differences between the uncompressed input and the VDC-M output. And as we can see, taking a very close look at the picture quality, as there are no differences. And what's really good about it is currently I'm running as low as 4 bits per pixel, which is 6x compression. Our IP core are now available. Some developers have started developing their next generation product with it. If you're interested, please come visit our website. On this station, we're showing a full implementation of the DisplayPort version 1.4 standard. So what I have is an FPGA board where we're incorporated the full DP 1.4 transmitter stack, and on the other board, we implemented the DisplayPort 1.4 receiver stack. Hardent worked closely with Xilinx, FPGA company, to incorporate our IP together to make this possible. So we've taken the Xilinx PHY technology with DisplayPort controller, and we integrated the Hardent DSC encoder and decoder, as well as the Hardent forward error correction IP to make an entire DP 1.4 demonstration. When you use uncompressed video transport, which is what DP 1.4 has been able to do for a long time, with this cable, there are no issues to transport video with a bit error rate of typically about 10⁻⁹. However, when you start using video compression to transport video, the benefit obviously is you optimize the bandwidth capability, essentially tripling the capability from 25 gigabit to 75 gigabit, but it comes with some challenges. Because when you have a bit in error on compressed video, it can show as a flickering rectangle on the screen. And this is why you need forward error correction. So in our demonstration, we actually put a noise generator right before the cable to show what would typically happen would an error occur. And as I'm turning on our forward error correction technology, we see the picture is becoming extremely stable and there are no issues. Our DisplayPort 1.4 IP core are now available. If you want to find out more information, come and visit our website.